yeah, as again, made a couple of changes to the equipment. I've added on the right hand side there, you can see as a heat exchanger I've stuck Intel's fan on it, right? Then to the left I've got the T balancer, which is software hardware that's has got a load of, it's got two, this one's got two digital sensors, right? I've got two digital sensors. One digital sensor I'm using conductive tape now, so I've put one digital sensor over to the heat sink on the fan. Then I've put another digital sensor just on one of the elbows, so I'm just monitoring the temperature of the oil. And what I've done with the software is I've set a target temperature of 30. Okay, so the T balancer then is switching in aggressive mode, because you can have different modes on the fan if you want it to be soft or aggressive. At the moment it's just set for aggressive. So basically the T balancer then is keeping the fan on and off now at my target temperature. Anyway, if you look down the left hand side on the bottom there, you'll see the cathode lamp I got running. Well, the ballast for it now is sitting in the lubricant that I'm testing at the moment, which is the oil. And I've got an analog sensor sitting in that for the temperature, and it'll probably just go up to ambient temperature, be about 25 degrees. So I might do some tests but basically what I'm looking for is conductivity. And as they said, the oil, the mineral oil or the baby oil is non-conductive, because the ballast now with all its integrated circuits are sitting in the oil, so I know that's sorted. So anyway, basically, yes, the oil does flow well. And I think if you wanted the oil to flow a little bit faster, because it may be not taking enough heat away, you're going to want it to be increasing, not necessarily the size of the pump, but maybe distributing pumps around the circuit, so you haven't got a high pressure point at any particular location. So we might be spreading spreading the load out around the circuit, you know what I'm saying? Because this gear we're using, like the EK gear, I haven't actually pressure tested it, so to temporarily assume that we're not dealing with high pressure fittings, like, do you know what I'm saying? So anyway, first things I'm looking to see as well is the oil now, right? What kind of sediment problems are we having with it? Do you know what I'm saying? So I think the simple thing to do, I'm more likely going to incorporate, is some sort of an oil filter. And it's more than likely going to be an oil filter from like automobile situation, where you're more than likely going to be filtering not necessarily engine oil, but a particulate around that sort of thing. So I'm going to be looking for a filter that's not going to be dropping the pressure too much. Do you know what I'm saying? So yeah, I've got the lower pump there, and that's running on vacuum, and that's giving us a vacuum, showing us a vacuum, because it's on the vacuum side of the pump, like, you know what I'm saying? But anyhow, I'm going to be adding more equipment to it. Then I'm going to be adding rads, and then also going to be more than likely going to be increasing the oil temperature quite high, just to see what happens. And then I'll probably do a separate test to see what the boiling point of it is. I'll do another test then to see what the flash point is, like, you know what I'm saying? And anyhow, they'll be on the following experiments. So I'll just quickly give you a zoom up of what's happening here. So basically, that's your once it focuses, that's your Intel heatsink, right, which is basically solid copper rings. I think that's a nice bit of kit actually, it's very nice. You can see the thing. You've got your EK CPU fit in there. Right, I'll zoom up on that a little bit for you. You can actually see, I don't know if you can see it yet with this, you can see, I like the clear fittings because you can observe the speed of the liquid, because we know that that is going to be a determining factor, is the liquid that's going through and taking the heat with it, and is it taking the heat. And then basically then we've got the T balancer. At first I had a couple of problems with getting the drivers to work for it, but I updated, made sure the updates were up to date on my Windows 7, and then Microsoft, fortunately, they were great help, and they helped me find the drivers. But the actual software, the T balancer software now, is very, very nice, I must say. Where is she? She's running now. I don't know if you'll be able to see it on the screen. It's going to be a good tool, because it's going to be able to help us with, it will monitor It'll also monitor flow gauges and tons of stuff, like, you know what I mean. It's just, there's just so much, you'll never get bored with it. So I would recommend it. Do you know what I'm saying? It's a nice bit of kit, like. So yeah, next time.